All right, we'll kick off now. Hi everyone, we're back. It's been about 3 months since our last meetup in February, which happened in real life and in another world. So I'm Tim. I'm the host for this evening. I'm a developer at Red Badger, and Red Badger organizes and runs these meetups. If you're a regular at React London, then hi, welcome back. How have you been? And if you're new, then hey, good to meet you. I hope you enjoy yourself tonight. We've got 3 exciting talks by 3 exciting speakers. So it's going to be a hell of a night. Probably the best night you'll have had since that Zoom pub quiz a few weeks ago where you came second, but you nearly came first. If only everyone had listened to you on that one question. So if you love what you're seeing and you want to talk about it tonight, then please use the React London hashtag. If you love it so much that you're inspired to give your own talk, then hit us up. hello@react.london, always looking for great speakers. If you're not sure how to behave, then check out the code of conduct, meetup.react.london. The TLDR of that is just don't be a jerk. And if you love badges, or you love the color red, or React, or pretty much anything else to do with development, then maybe you'd like to come work for us. So get in touch at jobs@redbadger.com. All right. So yeah, it's a bit weird doing React meetup a bit like this, but there are some advantages. You can set your own dress code. I've opted for a shirt. This is the first time I've worn a shirt in about 3 or 4 months. I'm feeling like fancy as heck. I mean, it's still in shorts, but that's the advantage of Zoom. You all could be wearing, well, whatever you like, and that's pretty nice. You got a great view from your seat, I hope. If you've not, then sit somewhere else. But you haven't got anyone like bobbing about in front of you and you're trying to see the screen. And you can go to the bathroom whenever you like. Yeah, you don't have to squeeze past people if you're busting. In fact, you can bring us with you if you like. Bit of company on the Lee. There are a couple of house rules. So this is the first time we've done this. Hopefully it'll be like smooth and professional, but it may all go wrong. So I'm just setting expectations here. Yeah, be kind, be nice. Ask questions. So we'll do a Q&A at the end of every talk. I think you should be able to, hopefully within the Zoom console, see like a Q&A button. So like click that and you can post questions in there during the talks, and we'll do our best to address and answer those after the talks. I don't know how we're going to choose which questions to answer. We'll figure that out when we get there. And switch your phones to silent. In a blast of nostalgia, I just thought I'd do a shout out just to make you feel like old times. So there is a reason for optimism in these kind of dark and scary times. I checked this chat out earlier today, and that shows the daily downloads of React from NPM. And as we can see in the last like couple months, there's been a noticeable improvement and massive increase in the number of people who are downloading React. So hopefully that's people who are homebound, they've got some time on their hands, they're maybe checking out what it's like to be a developer. So maybe in the coming months we'll see lots of new people joining the community. We'll see maybe more contributions, more packages, more libraries. Yeah, maybe the world will be the React world will be a better place. So going on to our talkers. We've got Just Make It Faster, Get Ready for a New Challenge by Luca Colonnello. Webpack 5 is almost here, an essential companion for our apps by Ambra Angelozzi. And Redux-Leaves, Write Once, Reduce Anywhere by Richard Ng. And first off will be Luca, so I will hand over to him.
Hey everybody, I'm just sharing my screen now. I hope you can all see if the platform allows. Cool. So I hope you are all good and enjoying the weather. 26 degrees, pretty hot, honestly. pretty good as well. But we're here to talk about React. So essentially, what we're going to do today together is a new project, or better, we're going to improve a project. So this talk is about React initial rendering performance. We're going to embrace all of this together and embark in this journey. But first, I'm going to basically tell you a little bit about myself. I'm a full stack engineer working at Trainline. Please follow me on Twitter if you want. I share most of the performance stuff. Pretty boring, but there is also some interesting stuff. I used to work for Sky as soon as I moved in UK, but then I jumped and went to Trainline, which I really love. I'm enjoying it so much. I have amazing colleagues. So yeah, check it out if you didn't use it already. Our app. And what I do at Trainline full time, basically since a year and a half or so, I'm being a performance engineer working mainly on performance related topic on the front end and a little bit in the back end as well, content delivery. And I want to tell you a bit about why I'm doing this talk. Essentially, the first thing, very important to me as the industry moves forward with new tooling and modern development techniques, I want to raise awareness about the impact of those techniques and patterns, if you want, on the speed of those applications that we build, as well as on the user experience, which is very important. There are some things that are slipping into our hands and we just don't know about sometimes. But also I would like to try and give you some tips on how to analyze those performance issues, as well as trying to solve the issues. And hopefully, if I can, helping you to improve the quality of what you're building. Very important. So sit back, relax, let's try to do this together. Close your eyes, and let's pretend you are a performance engineer working for a company, all fictional here, called Just Pay. We will see what it is about later on. And in this company, you get assigned to a new project, which is called Just Make It Faster, which happens to be the title of the talk. So yeah, what happens? You're working there and your CEO sends you an email and to all of your team and say, hey, I want to open the business to a new market. And so for that reason, we need to make our application, which is an e-commerce, faster in all of the low-end devices, which are devices who don't have a powerful CPU or maybe places where internet connectivity is not that great. So this is the product. This is Just Pay. This is what it looks like. Essentially, I'm going to walk you through all of the features. It's not very relevant to the talk itself, but I actually did all of these myself, and I'm not a designer, so please enjoy that. And let's talk a bit about the goal of this project. So we define interactivity and page rendering time as the two major metrics, and to avoid any, any issue here, I'm not going to talk specifically about the metrics themselves, but just the impact on customers. By page rendered, we mean whenever a customer can see something, from a blank screen to something rendered into screen. And by interactivity is the time by which the page feels most, or is and most, interactive, essentially. First, let's do a bit of a reality check. We all think that our applications are okay, and the smartphones are pretty fast everywhere already. But the reality is that as of March 2019, this is just starts. 26% of active smartphones worldwide were Android. But this actually differs from country to country, and you can see that essentially of these 76%, 20% were high-end, which means that there's a whole other range in these 80% of devices who were not high-end devices. So there's a lot of things. You can check this fact. And connectivity, well, globally, we're pretty good on 4G, but that's not always the case. We got places where it's pretty good, like North America and Greater China, pretty good. But there are other places where it's not as good. And you can see by changing here the select, where some places are still on 3G, some even heavier on 2G, where 4G is not really reaching out. So it's not true that every device has the connectivity that we would like for them to have to use our products. So I want to give you a small framework now to be able to assess performance. And this is what we normally do when we do performance related topics. So we try to measure first whatever is the metrics that we want to tackle. We analyze why they are whatever they are, and if they're good enough for us, and then we try and improve them. and we go on a loop forever, a bit like development is. So the first thing that we want to see and measure is initial rendering. So how long does it take for our homepage to get delivered to the user in this state where it's completely rendered when we first hit for the first time the website address? What happens there? And so I basically try to create this as a proper development experience. So this will be your console, and this will be the performance tab. For those who are not familiar, really just check it out. It doesn't really look like this, but it's a representation of that. And on the bottom, you will see the tasks that the browser is going through. And on top, you will see the waterfall, which is about the network. So as soon as we load the page, we basically download our HTML, our CSS, our JavaScript, eventually our fonts. And when the whole JavaScript kicks in, then this happens. So the browser is running our old JavaScript. After that, the layout phase happens, where essentially we download images and we create and construct all of the information about what the page looks like. And then paint finally happens. Those are basically the stages in which this happens and the order in which this happens. And you can see that only at that point, we can actually see something on the screen. So the time this takes is very crucial. So as we will be able to observe, if this was a real website that I could run now in front of you, the rendering will happen too late at this point, and it will definitely happen after all of the JavaScript ran. And we can also observe that the JavaScript execution is very large in proportion to anything else, and layout and paint are happening after our JavaScript runs. So why isn't the browser rendering while executing JS? So even if we had any DOM instructions happening within our JS, like anything really, any framework that is rendering could put any DOM instruction to append child or change this or that within the DOM tree. But really, as our JS runs in tasks, so every single task in our browser is blocking, essentially. Unfortunately, until that specific task we are running is done, anything else can happen. And so it doesn't matter if our JavaScript is asking the browser to render things or to calculate things or to change our DOM structure. It won't happen until the whole task is gone. And this is a bit of the reflection of what happens. So you have your task running your JavaScript, and then layout and paint happens. And those are essentially working like a queue within the browser. So I'm going to give you an example. This is actually something that I have extracted from a tweet. So this is a case where you're trying to render a lot of charts in a page. Think about like a dashboard. But you have to do a heavy calculation first, which takes about 1 second or whatever, real 1 second. And then you basically want to render all the charts. So to do that, you might be thinking, hey, I'm going to essentially just put a loader, a loading spinner, and after the whole calculation happens, I'm just going to render everything and then hide the spinner. So this is your expectation as a developer writing this code. But unfortunately, as the nature of this code is synchronous, everything that happens is just that you got nothing for the time it takes to run the whole script and then the charts. And so someone was asking in Twitter why this was happening. And essentially the reality is that this is what it looks like on a profiler session. So you got your spinner here, then you got your calculation, which is long, your rendering, same, pretty long. And then you try to hide the spinner. But in reality, the layouts and paint phase are happening only after, because it's all synchronous. So you're not really basically doing that. And your JavaScript might try to paint things and render things, but the browser is still unable to do that until the whole thing is finished. And therefore, the performance of your React app affects when the user is going to see anything on the screen if you are not rendering using the server-side rendering technique, which you're going to see in a second. So this is a user trying to wait for your websites. Now, bear in mind, these slides haven't been basically thinking of the remote thing altogether. So I can't see you laughing or anything. I'm just going to pretend you are and enjoy the laugh. So how can we improve the rendering time then? As I said before, server-side rendering can come to REST. This is not new. It's pretty easy. And the outcome of that is that we still download everything as before, but now the HTML came through to our client earlier because the server was rendering that already. And at the point of downloading the JavaScript, we can already do the layout phase in Paint. And you go, everything is being rendered already. And then we can basically do the whole JavaScript and make it interactive. That definitely improved our chart. People are maybe not bouncing out as much anymore from the rendering experience. They are pretty okay with that. We can see in different types of devices. This chart represents what we can see in different types of devices, high-end, low-end, 4G or Wi-Fi or 3G connection. And it seems to have improved across the board. So we are pretty okay with this and pretty happy about it. The page feels faster and is almost instantly rendered. Now, though, we want to measure the interactivity of this, which is way more crucial. And the question really we need to ask is, how does our JavaScript affect users trying to interact with the elements of the page after it's been rendered? So let's just look at what Just Pay does in terms of features. So we've got a simple home, and essentially when you click on the burger menu, you get this information. I won't bother with the names, but it's just to say there are different components in here. And you also got a basket, simple e-commerce, very similar to what Amazon or eBay could be. And you got a search as well, where you can basically just populate the search bar and search for things. You got some elements here where by clicking, you can see a pop-up of the product. So those will be like categories of top things, very similar to whatever an e-commerce will send. Some study content, some carousels of lists of products that people will likely buy, and then essentially the footer. So how does that work? When we try to click on the burger menu, essentially, at the point where we render the application, what happens if a user tries to click? So we can see the page, and we want to click on the menu. That's basically what we want to do. So let's have a look at what happens. Yeah, so that took a while. So let's see why that happened. Essentially, at this point, when your application is rendered, in React, with your JavaScript, we do something called hydration, right? And while that happens, currently it's a blocking operation. So it's synchronized and it's not being managed to be interrupted in any way. And so when the user happens to interact at any point while this task of hydration is still happening, there is a delay. And this happens only because your event handler then opening the menu can only happen after the whole task you're currently in is done. So the fact that we are blocking users in this way, of course, is not great. If the user tries to interact while the iteration is running, there will definitely be a delay, and it's only the case of when, at which point in time the user interacted. And of course, the user doesn't know that we are hydrating. And definitely what else we can observe is that our hydration step is very big. So I want to dive a little bit into this by explaining what this means. So we can see that we have a task here, and this is a representation of what happens in your browser. You have a task, which is running your JavaScript, and you have a high input delay. We consider high when it's bigger than 300 milliseconds, and then your handler is running. You can check these stats, by the way, on the web.dev website for all of the different metrics. They will be talking more through the theory of these. So why is our initial JS execution that big, though? So what is it made of? At this point, we go and analyze what's inside this hydration step. And the first thing we can observe, if we were to break this down, there are two main things here. There is a bloat of calls to a Webpack require, and then the React hydrate function. This is what normally happens in an application when you use Webpack, but it's very similar to when you use Rollup or other things. And really what is happening there, what they mean, what those two things mean. In a simple application, this is a representation of what a simple application could look like. Really the Webpack required cost, which is synchronized, is the cost of your imports, of your static imports. And then you got the cost of your hydration. So both of the operations are blocking, unfortunately, and therefore they depends how long they are, they might be creating a lot of work for the CPU to compute. So the amount of modules that we import in our bundle has a cost. And hydrating our React app is a linear cost, because the more components we have and the more cost we will have, essentially. By improving the hydration time, therefore, what we can basically say is that we're freeing the main thread earlier, meaning that our user can interact with the elements in our pages earlier. So let's have a look at how we can actually do that, because this doesn't seem to be anything provided by the framework. Well, again, joke, but yeah. Removing unnecessary worker first render. So that's definitely what we want to do. This is a very simple but useful concept. So just hydrate whatever you need for the page to work initially, and the rest can wait, essentially. So I'm going to try and do a bit of a profiling here. Again, this is what you will see in the dev tool using the React profiler, which is provided by React. And this isn't, it doesn't really look like this, is just a show. But yeah, essentially, these are the components that we have in our app at this point. And what it means, the colors, what they mean basically, the yellowish one means that this component took a lot to render itself, so without including the children. This is basically the time React takes to call your render function, plus do all the job it needs to do to render that component. And then all the children will follow. So if it's yellow, it's not too great. Otherwise, it's pretty all right. And what we can observe is that there are many components here, only one is bad. So actually, the problem here stands in the amount of components that are making this lower, not on the time individually they take. And when hydrating or rendering for the first time, unfortunately, the framework or the library has to go through all of those elements. It just can't skip any. So, oops, sorry. So here it comes, lazy hydration. So this is a technique. We use it as a Trainline with a custom library. So I have some experience in this, but there is also another library I'm going to show you. So essentially what it means is that instead of rendering the whole thing all together and hydrating the whole thing all together, I can hydrate most of the things that are important, for example, the ones above the fold, by essentially removing some of that cost earlier to then pay that cost later in chunks. So I'm going to then hydrate the rest subsequently when they are visible, when all of those elements are visible, which in this case means when users are scrolling. And what it means is that we can basically break this into smaller tasks and release the CPU earlier so that the event handlers, if there are any, can be handled before doing the rest of the job. So the key here is to hydrate as you go when needed, when elements are in viewport, for example, and don't hydrate what you actually don't need to, like static content. I have a little demo here. Hopefully Webpack Sandbox will work. Yay. So essentially what this is a simple representation of a list of counters. And those counters are turning to be green whenever they are mounted into screen. And originally, when they are server-side rendered, they are actually gray. And they are fully working. But you can see that basically as I scroll, those elements are getting mounted. And I am hydrating on top of them, so then everything is working correctly. So I'm going to show you how this library works later. The library is called React Lazy Hydration. And it's pretty good. It's open source. You can use it and check it out. And essentially, if I were to do this, probably in my application, I would have all of these things. But now by using this library, I can wrap the things that I want, saying when visible or SSR only, or when visible again. And then essentially I'm cutting almost in half the amount of components that I'm rendering or hydrating at the first render, which is pretty good already. 40% or around 40% less spent on hydration. Now we still have that issue of that big component. So I'm going to show you how to tackle that instead. And again, this is the time it takes for itself. So why is that component big? So if you were to analyze this component, you will basically discover that there is a big functionality here called build categories menu data. Again, this is fictional, but it's to give you, maybe you have similar examples in your app when you're calculating or transforming some data in the rendering. And what it does essentially is trying to grab two different set of data, all menu items data, which is a flat list, as well as the categories, which is another flat list. And it's trying to merge them in such a way that we can render this structure. So we have a category string, which is the name of the category, and many links inside. And this takes its own time. So what we could do to prevent these as an issue, we could essentially just hoist everything to the server using maybe GraphQL or any other presentational layer, and make sure that the client doesn't have to do that anymore, which means that it's not done in the server, it's not done in the client, it's just done by the API. But that is not always possible. So we can also try to use something different. I didn't actually build this, but it's just an idea. You could basically reuse whatever you did in the server side during the first server side render. You could reuse that calculation in the client with a simple hook using context. So you might have the JSON data coming back from the server within the client, and then you just reuse that data instead of essentially just redoing the calculation again. And now by doing that, we can see that this block is not yellow anymore, and we just saved another 10%. So yeah, we definitely improved interactivity as well. This is still making some users unhappy, the one with the very low-end devices, but overall, they're not bouncing out anymore, and they actually feel pretty all right about our website. So yeah, you made your customers now happy, and your CEO as well. This GIF is for the people that were actually sleeping during the talk. You can pretend you're clapping and you weren't sleeping. So yeah, just to recap again, you can use SSR to deliver content to users earlier. This is very good for performance. You can paint everything as you need earlier. You don't need to hydrate everything. You can hydrate just your needs, just what you need, and you can pragmatically pick and choose the elements that you feel like are the most important for your customer and your application. But also, you can hoist as much as possible to the server, or use techniques like the ones I showed, where you can see that some components are too heavy, maybe entering too much or too much data. So you can definitely reduce the amount of load that these components are carrying with them. Also, I want to have a small postscript in here. So React is making this easier. So the new version, if you have followed the React Conf 2019, the new version of React, which is already running in FB5, is actually coming with progressive and selective hydration, which are very similar concepts, not the same, but they solve the same issue essentially. It's all about releasing the CPU earlier, so avoid to creating any blocking and synchronous tasks and big tasks. And another important thing to say is that you've got to bear in mind that you can only optimize so much. So you need to give your application a budget for your hydration or anything else. And then whenever you feel like anything that you need to build will basically make you go over budget, if not tackled, there might be a scope creep or whatever, or maybe it's not even feasible to not go over budget. You need to make your product owners or the business anyway aware of the impact of those new features to essentially make sure that they are on board and that they know the downsides of what they're adding to the page. I think I'm done. I just want to say some special thanks, first of all, to Red Badgers for hosting the meeting, the meetup. This is very good, and I think is working great. But also to Trainline in general, my company, to give me all of this time to prepare for this, because it actually was pretty tough to do all of this work. But I enjoyed it so much, and I got so much support from all my colleagues and my managers. So thanks everyone, and all the friends and colleagues that are currently watching as well. And thank you for listening as well. I know this has been pretty fast-paced and also pretty intense. But yeah, if you have any question, I'm pretty happy to reply.
Awesome. Thanks, Luca. Clapping. Imagine 100% people clapping and screaming and throwing stuff in the air. Standing ovation. Yeah, really good. Thanks very much.
Thanks.
You nearly got away without any questions, but Joanne Vicaria has, I've butchered your name, I'm sorry about that, has just posted a question. And if anyone else has got any questions, then write them up now whilst we're answering this one. So the question is, great talk, Luca. Would like to know, is there any risks with lazy import, for example, making the page not crawlable by Google and therefore not getting the SEO value?
Yeah, no, absolutely. There's actually no risk. So in these kind of techniques, really what you're doing is you're rendering everything in the server already. And the only place where you're acting really is the hydration. So what you're trying to do is to make sure that basically by hydration, what we mean is to, add all of the event handlers or anything really that you might need for your interactions to happen, and for React to connect all of these events, essentially. And at that point, your content is already there. The only thing that is missing is the interactions on top. And so definitely the SEO and the crawlability will be perfectly safe. We do this at Trainline. We have pretty good SEO pages and they still work pretty fine. But what you're doing is to basically make the CPU of any mobile phone or customer happier, essentially, because you're breaking down these big chunks of work that can then happen instead at different points in time when the user needs. Yeah.
Awesome. All right. So next up, I think there was a question actually in the chat, which is a bit unofficial, but we'll take it, from Anthony, which is, what performance logging or monitoring tools can you recommend, if any?
Oh yeah, sure. So at Trainline, but I think many companies do that already. We evaluated many of those tools. My personal favorite is SpeedCurve. SpeedCurve is actually a tool where you can basically try and test your application day by day, or after deployment, or every hour, or whatever setup you really fancy. And the great thing about that tool is that it gives you a lot of insights. It's based on webpagetest.org, which is another tool you can use, but it doesn't, webpagetest.org doesn't collect information. SpeedCurve is more like a dashboard where you can essentially collect the history of all the reads, and it gives you some very useful insights like third parties, first party. It gives you a lot of metrics. Some of them are calculated. You can create dashboards. It really looks like, I don't know if you use stuff like New Relic, for example, but for performance. I really recommend that, and check it out. But there are also very valid alternatives. There are people that are just building Grafana dashboards on top of Lighthouse or webpagetest.org as well. But I think SpeedCurve is worth the money for what it does, and I can tell that it's very good, and it's been recommended by many people as well as Google. So I think it's a great tool, and it's growing so much.
All right, great. On to the next question, which is from George, which is, hi Luca, great talk. Any suggestions or techniques that you can recommend to catch the hydration using the profiler component from React?
Oh yeah, that's a very nice question. Actually, I wanted to put it in the talk, but I was afraid it was too much. So what we do essentially, we have two different metrics that we introduce. One is called boot duration, another one is called hydrate duration. And so this will require a lot of technical explanation that can't happen just in a spoken answer. But essentially what we do, we try to measure the time it takes from the very first time you do a React hydrate, so before doing that instruction, to the end of that operation. So the hydrate functionality gives you the ability to add a callback to whenever React is done doing that. And so essentially you can just do a performance mark before and after, and then you can create a measure. And that's what we do. We call it hydrate duration. The nice thing about this is that if you use tools like SpeedCurves or any other tools that are performance-based, like Webpack, Page Test, or other tools like Lighthouse or Page Speed Insights, they automatically log out for you anything that you tracked using the user timing API, which is custom in that case. And so you will be able to see the trend. And we do that for the lab instrumentation, so we can see these in SpeedCurve or Lighthouse, but we do this also in New Relic, so we can see the real time on the real user metrics, what users are currently doing. And we can basically see what is the worst experience. So we got some people maybe having 1 second of hydration, and some other having 150, even on mobile, maybe some very powerful iPhone, like iPhone 11 or whatever. So it's very nice to see what is your worst and your best, and then you can essentially compare. So I really recommend doing that. And yeah, I mean, I might actually do a write-up about that at some point.
Awesome, thanks for that. Okay, so there's one last question, which we'll take today. So that's from Nick, and the question is, cheers Luca, great talk. Any hints about how to automate monitoring of React rendering performance over time? Any useful tools you've come across to achieve an understanding of this?
Yeah, that's actually a very challenging thing. So for a few reasons, again, SpeedCurve can totally help. We use SpeedCurve to do deployment as well, as in whenever there is a deployment, we are triggering a test in SpeedCurve to see if there is any regression. But definitely the pre-deployment, so CI or even locally, it is complicated because the variability of your machine running this as opposed to what a real mobile device could be is very high. So you have different options out there. So recently, the React team published a new API for performance in React, which essentially gives you all of the insights that you will get in the developer and profiler tool, but in a JSON format. And so essentially what you can do with that, you can write a pragmatic test, even in CI if you wanted to, using Puppeteer, for example, and then check all of those, basically what are you can do analysis of what are the worst components or the best or how long it took or whatever. The challenge there really is about the viability of the machine that runs that code. So if there's no consistency between the CPU cycles, and maybe the agent who was running that code in CI or locally was busier, you will get different results. So I didn't come across really a tool that solves that well, although SpeedCurve, for example, does have a solution for that, which allows you to integrate their infrastructure, which is consistent across every run, in your CI. So you will need to open your network for them, but totally you can do that. You can basically test this in staging, and you will have the whole set of features, and it will be automatically provided to you.
All right, awesome. Okay, that's all the questions. Thanks again, Luca. That was a really great talk. Clapping. I think next time I'm gonna have to get like an actual applause track and actually like put it on so you get a sense of what it's like to be in front of everyone. So the moral of the story, I think, I got from the talk was like hydrate little and often, especially as we get into summer. Right. So I'm going to just share this briefly, just as a transition. So our next speaker of 3 speakers, this is 2 out of 3, will be Ambra Angelozzi, talking about Webpack 5 is almost here, an essential companion for our apps. So yeah, sit back and enjoy this. Ambra, if you want to take over. Stop sharing.
Thank you, team. Okay. Yeah, hello, everyone. I am Ambra. I'm a web engineer in Trainline. I'm part of a team called Tango, which takes care of the website from the homepage all the way through the checkout, mobile and desktop. I've joined Trainline about a year ago, and I decided to do this talk about Webpack because I've always felt like I wasn't super familiar with the tools I used to build my apps. And I've always tried to avoid them as much as possible until before joining Trainline last year. And in the last year, I've been working a lot on refactoring the builds and improving performance and so on. And I actually started to appreciate and understand these tools. So this talk is not about the Webpack basics, but I wanted to highlight what the new release, which is currently in beta, is bringing us. So what new tools are we going to use in the future? So yeah. So why do we need Webpack at all? Webpack is a static model bundler. So it takes all the code from our application and makes it usable in a browser. But if you think about it, the modules that we use on a daily basis, like CommonJS, CS modules, AMD, and so on, they don't work in the browser out of the box. They're just like a way for us to share units of code in a more manageable way. So what Webpack does is it strips out the imports and the exports, and it makes them executable and bundles them together. On top of that, also takes care of preparing other assets like CSS and images and so on, and optimizes that for performance and caching. So it's a well-rounded tool that we probably couldn't live without at this point. What can we expect from this release? So first of all, as I was saying, there is no due date yet. Webpack 5 is currently in the last stable release is number 4. Webpack 5 is currently in beta, so they're testing it. But if you have a look at the changelog page, it's actually quite complicated. And when I had a look at the first time, I was like, well, there were things like persistent caching, improving long-term caching, and tree shaking, and so on. And it was quite confusing for me. So I've tried to break down in here what are the benefits for us devs, and how our development experience is going to change when we're going to upgrade. So wouldn't it be nice if we could, from the upgrade on, deploy multiple times a day with minimal impact for our users? What do I mean? Like, some people might think, well, we can deploy already multiple times a day. Well, you can, but right now it's not optimized. It's not ideal, because what happens when you do a deployment is that Webpack, the Webpack config, based on some criteria, tries to split your bundle in smaller bits called chunks. And Webpack, to avoid conflicts, will try to will append an hash to the file name to make sure that the browser actually caches it. And when that file name is not valid anymore because the content has changed, the browser will ask for a new one. But what Webpack actually relies internally on is not that hash that you see there, is the chunk and modules IDs that are assigned. So every chunk has an ID, an internal ID that Webpack is using. And what happens when we update a dependency or we change the order on the inputs? Like, this simple operation can actually change the chunk IDs and the module IDs, invalidating the content of our chunks as well. So for instance, let's say that you have invalidating vendors because you've updated a dependency. But in doing so, actually the chunks ID are changing. And because main, for instance, is referencing vendor, calling it by ID, the content of main itself will change, and the hash in its file name will change as well. There are other optimizations that are like extracting the runtime, for instance, and other things like that are not immediately easy to do in Webpack 4. So there are some plugins that allow us to give us names to chunk, so the reference changes less often. But the reality is that in Webpack 4, optimizing for long-term caching requires a lot of difficult configuration and optimizations. And so one of the asks from the Webpack community to the Webpack team was to make this process simpler and available as default. So what they did with Webpack 5 is including a new, more deterministic algorithms that optimizes for long-term validities of the files and doesn't invalidate the chunks as often as before. So this is what they've included. There is a small downside, which is that there is an overhead in terms of size. So we will need to understand if it's better for you optimizing for size, as it was before, or optimizing for long-term caching, and decide some trade-offs. It's enabled by default to the new release. So if you don't want it, you will need to opt out. But it's probably something that a lot of companies nowadays are interested in, because we deploy more and more often. So another thing that would be nice to have is to start our project faster than ever. What do I mean by this? What they've introduced with Webpack 5 is it's a nice idea called persistent caching. Persistent caching, imagine how many of you have in the morning, you come in the office, well, not nowadays, but usually. You know that your build is going to take a few minutes, so you come in the office, you start the build, and then you go for a coffee. I really hope my manager is not watching. Anyway, well, after the first build, because the first build is going to be pretty much slow, and after the first build, you will have an in-memory cache. Webpack will build an in-memory cache, right? So every subsequent build will be much faster. So they thought, well, why don't we write this in-memory cache to disk to speed up the initial build. Because in theory, that should speed up the initial build considerably. And so that's what it did. Imagine that you've got a cache on disk when you start the first build. The first build is going to be probably faster. Not as fast probably as an incremental build, but faster. At that point, after the first build, Webpack will rebuild the memory cache, which will be written on disk at idle time. So when the compiler is not doing anything else, it will try to synchronize the cache in memory with the cache on disk. And then you will have your usual incremental builds that will be fast as usual. And there won't be any more coffee time for anyone. Seriously though, I'm running some tests. Obviously this is not scientific, it's like tests that I've run, but I thought they were pretty impressive, so I decided to include them in the slides. So I've got an index file, which is pretty simple. It's importing a module, and I'm importing a library as well because I needed to see like how to splitting out chunks. I've enabled persistent caching at this point. And so I'm running my first build without a cache because I don't have it yet. I run the initial build, and these simple 2 files take 449 milliseconds. After I've run this and it's finished, at this point, I've got my cache in my Webpack cache on disk. And when I run my build again, it's gonna take considerably less. We are at 220 milliseconds. Obviously, like, this is a very small test. Imagine how much this can improve in a bigger project, and how much benefit it could bring in our development. What is interesting about persistent caching, though, is the technical challenges that they had to face in order to achieve this. So I've decided to kind of recap them here. I'm not going to go into much details because it's quite technical, and it probably would have required much more time. But what is interesting is, for instance, we're writing complex modules on this, because in the Webpack cache, in the Webpack memory cache, there are basically modules, and like JavaScript doesn't give us a mechanism to, write serialized modules out of the box. So they had to write their own. They had to change how the compiler works to make sure that was actually only writing at idle time, so it wouldn't impact our development too much. So there are a few technical challenges which are very interesting, and I suggest you go and look at, especially if you develop your own plugins for Webpack, which I think you would probably appreciate. What else? So other things that would be nice to have is improving our performance without knowing it. Now, this seems a bit out of place, considering all the effort that we do to improve our performance. But actually, with Webpack 5, there is a new and improved tree shaking. There is improved tree shaking. So tree shaking is a term used in JavaScript just to refer to dead code elimination, right? And it relies on imports and exports from EX modules. In Webpack 5, tree shake is in 5-tuned. So we've got 3 additional types of tree shaking now. We've got nested tree shaking. So I've got a simple example here from the code. An inner file, which is importing a constant A and B. Module is importing inner and exporting it. And then user is finally using module, but it's using one of the properties of the inner file, only A. Webpack is now able to track access to nested properties. So in this case, Webpack will be actually able to understand that B is not used at all and remove it. Also, inner module tree shaking has been improved. So Webpack 4 wasn't analyzing dependencies between exports and imports of a module. But Webpack 5 has a new option, which is enabled by default, that runs an analysis on the modules and actually can figure out the dependencies between imports and exports. So in this case, for instance, we're importing something at the top, then we're using it in a function, and that function is used in another function that is exported. Webpack 5 will figure out that actually the import something is used only when that export is used, and it will be able to eliminate the code that is not needed, which is pretty impressive, I think. And also, for one of us that spent the last year migrating to ES modules, now CommonJS is actually tree-shakeable with some limitations. So there is additional support for some of the CommonJS construct, but it's generically more tree-shakeable than it was. And so, yeah, you would be happy to know that it's low effort now, like relatively less effort now, to improve our bundle size. Okay, so another thing that would be nice to have is being more aware of our polyfills. The polyfills have been removed, core node polyfills have been removed from the Webpack build. Why is that? So some of the modules that we are using, imagine that you've got some source code that you want to deploy to the browser. And some of the modules that you're using are actually native Node modules, and their API is not available in the browser. What Webpack 4 used to do is when it was compiling the browser, it would add automatically some polyfills in order to allow you to use that functionality in the browser. An example, like a really super famous example of this is crypto. So if you have, for instance, like e-commerces or you have like payment pages, most likely some of your modules will be using crypto, which is very common, yeah. Webpack 4 would have usually added a polyfill for crypto because it's not supported in the browser, but Webpack 5 doesn't anymore. So why would you remove the polyfills, right? Well, first of all, because the aim that Webpack had was to allow us for running most of the Node.js modules in the browser, even if it was technically not possible out of the box. But the module landscape has changed a lot, and now many modules uses actually that are now specifically written for the front end. And so like we can choose to use modules that are more front end friendly and get rid of the polyfills. Polyfills are often large, like for instance, crypto's polyfills that I was mentioning before, it's like 300 kilobytes uncompressed. And so it's quite, if you are not aware of the fact that it's in your bundle, it ends up being quite heavy. And also they're often out of date. If you think about it, a breaking change, because they were included in the Webpack release, a breaking change in Node would mean a breaking change in the polyfill, which would result in another major Webpack update. So to kind of remove these dependencies, they decided to just remove the polyfills. What are the benefits for us? So first of all, we will be more aware of what's in our bundle and what is, adding size to it, increasing the size. And we can try to use more front-end oriented modules. But also, if we need to install a polyfill and you can't, just do it differently, you have more control about what you're installing. You can decide the version and you can opt in specifically for it, but it will be a more informed decision somehow. What it would also be nice to have with the new release is a better dev experience. So I think I really like this bit. Webpack has gone through a modernization. So to implement all this new functionality, and also with the aim of making Webpack more stable for longer. So the Webpack team basically decided that we don't need to upgrade as often as before. and they want to give us a tool that actually we don't need to go through a major release anytime soon. So they went through an internal restructuring of the code, and they removed a lot of technical debt, reduced the technical debt, applying some of the modernization to the platform, which is the reason why, for instance, the support from Node 6 has been dropped, which with latest support version being number 10. Also, they've started using internally more modern structures like sets and maps and so on. But there are like many things that have been done, which are worth looking at. But I think it's nice that they've gone through the effort of remodernizing the platform and making it more stable. And yeah, when you upgrade, make sure that you've got all your plugins updated first, because otherwise everything will break. But yeah, the last but not least, which is probably more relevant for the React community, is micro frontends. So there is a new merge proposal called Module Federation, which some of you might have heard of, which allows basically a JavaScript application to load code at runtime from another application, and also in the process share dependencies, which is quite powerful. So what I mean by this is, imagine that you've got these two apps and you want to share some components between them. So for instance, an app bar. And maybe you're using Material UI on app 1 and you're using style components on the app 2 or wherever, but you don't have all the dependencies. You want to share those as well. The options that you have right now are probably create an NPM module out of this navbar and share it, or use techniques like edge side includes, but you will still like rely on you will need to deploy code somewhere else. With Module Federation instead, as long as your project is deployed somewhere altogether, you don't need additional support. You basically can expose some of the components at build time. Like you can tell your Webpack build that some of the components will be used by other applications, and you will be able to load them when you need them from other apps, and include dependencies as well, which is the powerful bit. Some of the advantages of this are, first of all, like for instance, like self-healing applications. If there is a network failure or whatever, you could always query another app and get their copies of the missing dependencies, for instance. You will have smaller bundles. You can share the configs between applications. You can have a team, that manages, for instance, let's say that you've got two websites and they share the footer, a team that manages the footer, and when they update, it just updates automatically on your app as well. Like you don't have to do anything else. I think it's going to be like pretty powerful. As I said, there is a merge proposal in the Webpack core, and I've prepared a very small demo for this, which I've forked from another demo, which is more complete. But I think I just wanted to share a few things. So I've prepared a small application 1 and application 2, which should be here. Nice. So I love plants, so it's plant theme. If you can see, we've got application 1 is sharing like a page. There is a navbar. This is Material UI. And application 2 has the same navbar because they're sharing the construct of the page. Material UI is themed, and I want to point out that actually I can keep the theme as well. So like I can modify the theming. It's gonna just accept it as it is because it's just sharing the component. I'm gonna share the code in a second, so it will be easier to understand. But as I said, I can share components. For instance, this button here, which is style components. It's used in the application 1. Here it is. And if you have a look at the network tab, it's actually loaded from the second app. So it's localhost 302, which is my second app. And because I don't have style components installed here, I'm actually including the dependencies as well. So the vendors related to that button comes with me, comes with the app, with the second app basically. And I'm doing the same for the dialog, for instance, and the image configs. It's just an array of like configurations for the images that I'm using in a different way here and here. So it's quite powerful. And if we have a look super quickly at the code, in my Webpack config, all I have to do is I've got my module federation plugin. So I split the screen into. We've got the config of the first app on the left and the config of the second app on the right. As you can see, I'm just determining the name of the apps. The remote entry, I'll get to this in a second. And then I'm gonna consume some components from remote app number 2. And the same is doing remote app number 2. It's like consuming from app number 1. And app number 1 is gonna expose the page component. App number 2 is gonna expose for other apps to use the dialog, the button, and some config. So if we look at the code, this is my app. And what I'm doing is I'm importing page exactly as if I would normally do with one of my modules from the app 1. And the same I'm doing here. I've got my grid list, which is just the small image list that I had on the first website, which is getting the config from the second app. And it's also getting a dialog, which was on the button. All of this is possible because this Webpack config will split out separate chunks for the components that I want to share, and then we'll create a remote entry. I'll call it remote entry. You can call it whatever you want, really. That will be included in my index.html and will allow me to actually include other applications. This is left there, but yeah. It will allow me to include other applications entry, and it will tell my Webpack where to load the components that I need from, which I think is quite spectacular. I'm really expecting a lot from this technique. I'm very excited. I hope it's gonna take off. I can definitely see the benefits of it. And I think this is it. So if you have any questions, thank you for listening.
Awesome. Clapping. Thanks, Ambra. That was really great. I'm just going to leave a pause for everyone to just finish clapping at home. All right, cool. Do we have any questions? Anyone want to post any questions in the Q&A? Anyone Webpack 5 curious?
I feel like I'm the only person excited about this.
Okay, I'll give it a few more seconds. Oh, there was a question. Okay, cool. You nearly got away with it. So the first question is from Will. What happens if modules fail to load with module federation?
Well, you can have some fallbacks, right? So you can like, for instance, if you can lazy load it like with lazy and suspense, and you can put in place some fallbacks if you want. But you can basically treat it as a normal module as you would in your application.
All right, cool. Okay, that's done. Juan asks, can we use this now?
Well, you need to upgrade to Webpack 5, which is in beta. So you're cool. But in theory, after that, yeah, you can use it. I don't like. I haven't used it personally aside from demos and stuff, but I'm guessing it will be like, it will be more supported and stuff probably in the future.
Next question from Royston. How would versioning work with MFE?
I don't know. Why don't you try it out and let me know? No, I'm kidding. I don't know exactly. I think there are some things that probably they have worked out. I've tried breaking the contracts, and it was breaking for me. Like I had obviously runtime errors, but I'm guessing that they will put in place some more stable thing.
All right. Next question from Hugo. What do you put in the remote entry.js file you mentioned?
Am I still sharing? Yes. So I don't put anything in it. Webpack puts, and gone. I'll share one, if you guys can see. So Webpack it's just like the normal Webpack build. So it will tell this is app one, and when I call page, this is what you need. This is the chunk that you need to return. So that's why you do it at build time, because it will just include the whole, sorry, I'm missing the words. It will just include the whole chunk, and we'll be able to load your modules.
All right, cool. It turns out people actually really love Webpack. There's actually quite a few questions now. I'll do a couple more because I'm conscious of not going too late tonight. Next question is from Tom. How does module federation deal with varying versions of sub-dependencies of a shared vendor library? How is tree shaking affected?
So I'm guessing that, yeah, I don't know. I've been asking myself the same thing. I don't have like a big, I haven't tried on a big enough example to see like how tree shaking is affected. And I'm guessing that you're sharing the sub-dependencies of the same version that you need. So in my example, I was sharing like style components for the version needed for that component, because that's what I wanted to do. But you can specify which dependencies to share. So I think that would be probably easier to customize.
Cool. Okay, I'll do one more question, and then perhaps Ambra, perhaps you could give typed answers to any other questions if you like.
Okay, like you guys, like if you want, you can put me or something.
So the final question that we'll take is from Adrian, which is, I imagine module federation could be abused a bit, like LeftPad was. Does the link between my code and the remote happen at build or runtime?
That happens at a build. So at build time, you need to specify the remote, and the remote is just a Webpack file that loads the modules. So all the preparation bit happens at build time.
Okay, awesome. All right, so I think there's 3 questions remaining. I'll leave them open, and Ambra, if you do want to give answers to those, let's talk then
okay, thank you.
Okay, great, thank you. Thanks again. Claps, claps, claps. Okay, cool. And now we move on to our third talk. So that is Redux-Leaves, write once, reduce anywhere. So I've got a short intro for Richard. He was the only speaker to do his homework and send me an actual intro. So here's looking at you, Luca and Ambra. Richard started out as a maths teacher in a secondary school, switching into engineering at an edtech startup, then switching back into teaching as a software engineering coach at an edtech scale-up. Last Friday, he embarked on his latest switch, handing in his notice to launch a new tech upskill community startup. When not pivoting his career all over the place, he enjoys writing code, writing documentation, and writing short introductions for other people to read out about him. All right, I'll hand over to Richard now.
Thanks so much, Tim. So I'm here to talk to you about a library I've written called Redux-Leaves, which I've shamelessly slapped tag on write once, reduce anywhere, which does actually capture the essence as well, obviously riffing on common themes. And what it comes from are the kind of looking at different complaints about Redux. So people say Redux is tedious because you want to do like a very, very simple state change, and it's such a faff to do it. Or there's a big learning curve, especially when developers are new to Redux. They just got no idea like what all these different words, action creators, actions, concepts, like it's just lots of hoops to jump through. And even if you know what you're doing, there's a lot of boilerplate, and it's just like tiresome to like have to maintain all of it. So experiencing all these problems, I personally, really like Redux, but a lot of people complain about those things. And so I thought, well, is there a way we can make it better? And I thought, okay, in order to make it better, we want to make sure that it should be quick to set up. Maybe try and provide a more intuitive API so it's easier for somebody new to it to pick it up. And also, we want there to be minimal boilerplate so that as developers, we can just make things, get on with it. So this sounds great, right? So you think, well, what's the way we learn about something like this? And maybe that's coming to a talk or something. Oh yeah, sorry, there's a bonus. We want it to work with Use Reducer because maybe, we're using Redux now, but at some point there's all this chat like concurrent mode, maybe Redux won't work. Like we also want to be able to use it with Use Reducer. So how do we find out about this? And in order to do that, I'm going to whisk you away to the Redux rave party. So you can see here, we've got some initial state for my Redux rave party on the left, some event details, title of venue, and then some stuff relating to the rave party on the night. There's some announcements, some food, pizza, sushi, and some persons inside. So let's go check it out. So this is the Redux rave party. And we get there, and basically the organizers are like, oh, you know what? I've left it too late to kind of get going the organization of my Redux rave party. Like, it's got to happen like right now. But unfortunately, I haven't had time to set up my reducer and my action creators. And there's a big problem. Big problem being that my venue is not accessible. Please help me. And we're like, yeah, cool. We got you sorted. We know how to do this. We know how Redux works. And so you might think, okay, what should we do to do this? And if you were to write this manually, you might do something like this. So you start off with, we've got our action creator, make venue accessible. It's a function that returns an action of type venue made accessible. I've got my reducer, take state, action, use a switch statement of action type, and I'm handling this specific case. And this was like a bit nested, so I'm having to do lots of spreading to spread out the different state, make sure I'm not mutating, not losing anything. And finally, after I spread it out a couple of times, I get to, yep, that's the state I want. I'm going to spread out the other things inside it, and it is accessible is now true. Great. Then I can create my store from the reducer and dispatch this action that I've created to that store. Perfect. That's 21 lines, but it's also quite tiresome and ugly to look at. And can we do it better? We can. The first way we might try to make it better is by using Immer. So I'm not going to go into Immer in depth here, but it's a nice library. It lets you write immutable updates in a way that feel mutable, basically, because you're not actually operating on the underlying state. So here, you're just kind of saying your state event details of venue is accessible equals true. And Immer will make that a nice immutable update for you. And that gets us down to 13 lines. And that's better. That's better. Because it was 21. Can we do better? I think we can. This is another library called Redux Toolkit, which is officially recommended by the maintainers of Redux now as a way to work with Redux. And again, it's a little more efficient. And so it's using Immer under the hood as it happens. Here's some gains we've got now. So there's a create action kind of export. And there's this nice feature where kind of you use a create reducer export as well. And kind of rather than having to like duplicate your kind of case logic, you can, it calls to string on this thing here, which will return actually the action type is passed in here. So it's quite nice. It gets us down to 9 lines. Cool. So we've gone from 21 down to 13 to 9. It's improving. But there's still like one thing which makes me really uncomfortable here, which I don't like about any of these, and that's that they're painful to scale. And by that, what I mean is, okay, when I use any of these, I'm handling a very specific case. I can now make the venue accessible. But, there's still so much I need to change. Like, what if I want to increase my capacity? What if I want to add an announcement? What if I want to change the number of pizzas? And I've got to do, like, all this, like, for every single case. And I hate that. It takes so long. It's all about hoop jumping. I just want to get on with it. I just want to make stuff happen. So I thought, well, okay, can we do something about that? And that's why I wrote Redux-Leaves. So Redux-Leaves, here's what we do. You import Redux-Leaves. You need some initial state, and you pass it to Redux-Leaves. And that gives you two things. That gives you a reducer, and that gives you an object of action creators, essentially. So this is all done for you. Then you pass your reducer to the store. And then we're basically describing the change we want to see based on our actions object. So if you remember, it was state.eventDetails.venue.isAccessible. I'm going from actions instead. So actions.eventDetails.venue.isAccessible. I want to create an action at that point in my state tree. So there, I'm going to create an action. What action? Maybe I want to toggle the Boolean because it was false. Now it's going to be true. And that's how you would do that using Redux-Leaves. I'll show an interactive demo in a bit. But I think what's important to emphasize here then, essentially, is it really comes down to these two lines, because this handles essentially arbitrary cases. So unlike the other ones where I have to create a new case every single time I want to change a new bit of state, with this, those two lines, that's it. Now I can start modifying my state. So I'm going to show you that in action now. Let's see if I can fork this. How do I do that? I'll just copy all of this. So in my new notebook, what we're going to do is we're going to require Redux-Leaves. And I've already got my initial state here. So all I'm going to do then is say my reducer and actions. I'm going to destructure that array from Redux-Leaves, pass in my initial state. I'm going to create store. My reducer, I've already got it. Cool. Didn't have to write anything. And what do I want to do? I want to make my venue accessible. So what that was, again, is you're kind of tracing out change. So the change which you'd want to see if you're just directly operating on state is state.eventDetails.venue.isAccessible. But I'm going to use my nested action creators instead. I'm not operating directly on state. And that's where I want to create an action. And what kind of action do I want to create? I want to create a kind of toggle. So I want to toggle it from being false to true. So that's the action I'm going to kind of dispatch, and then I'm going to get state after that, and let's see what happens. And what you see in the state we get back, I can see my venue is accessible, true, is open, false. What I said, the great thing about Redux-Leaves is now you can handle any kind of arbitrary case. So let's, to make it a little bit more efficient, I'm just going to destructure my dispatch and get state. So now let's dispatch, let's do the same for is open. So actions.eventDetails.venue is open. There, I'm going to use a kind of, you can do it another way. On will just make sure that the state is true, essentially. And then I'm going to get state. And now I can see that I have here indeed, is accessible true, is open true. Cool, let's see what else we can do. Right, now we're ready to go. Let's make an announcement. Maybe we want to make two announcements. So let's grab the action creator to make an announcement. So make announcement. That is at actions.onTheNight announcements. There, I want to create a push. I want to push into that array. So that is my action creator stored there. I'm going to dispatch twice to make two announcements. First announcement is I'm going to say the party is ready to go, and then I'm going to dispatch another announcement, and I'll say, and it is lit. And let's get state after that. And then I see, because I dispatched two things in my announcements rate, I've got two things, party's ready to go, and it's lit. Fantastic. And all the people are going to come flooding in now. They are so hyped for this party. So, whoops, sorry. I want to then add to my queue actions.onTheNight. Where have I got it? Persons.queuing. Create increment, maybe 100,000, let's say, and get state. So now I have 1,000 people queuing. Let's let them all in. What I want to do now is I want to kind of, in a single dispatch, get these 1,000 people from queuing into inside. So here's what I'm going to do then. I'm going to dispatch actions.onTheNight.persons. And now I want to act on the whole of this object. So I'm going to create an action here rather than on queuing. I'm going to create a do action, which is basically taking a callback. So that callback is going to operate on that leaf state. What I want to do is I want to return the state I'm replacing with, and I'm going to return my leaf state dot inside, sorry, that should be the inside property, should be leaf state dot inside plus leaf state dot queuing, and queuing, I want that to be 0. So it will execute, it will reduce basically using this function on my person state. And now let's get state after that. And hopefully, great. And now I see 1,000 people all inside and not queuing. Now the problem is, because I've got 1,000 people inside, my food's gonna go. All my pizzas are gonna go and all my sushi's gonna go very quickly. So I'm like, well, what I could do is I could dispatch something to make this 0, make this 0, make this 0, make this 0, make this 0. Oh, that's repetitive. I don't want to be repetitive. What I would like is some kind of generic reusable logic, ideally, which is something like actions.onTheNight.food.pizzas create set all properties to 0 or something like that. That's what I'd like. And then if I had that, then I could reuse it on sushi as well, and that'd be just nice and cleaner. It says, oh no, this isn't a function. Yes, okay, of course, because Redux-Leaves gives you lots of things, but doesn't give you this one by default. That's okay, we can add it in. Let's add it in. So let's write our generic reusable reducer. What did I call it? Set all properties. So set all properties. This is going to act on some generic leaf state. And what I want to do is I want to say that my keys are my object.keys from leaf states. That'll give me an array of the keys. And I'm going to create some entries. So, and that'll be, I'm going to map my keys. I'm going to map each key into an array where the first should be the key and the second value should be the value I want to set. I want that to be dynamic, so that should come from my action. So it should be my action payload, really, so that I can control what value I'm setting to. And then, because I've got these entries, so this is an array of arrays, I can now return object from entries. And I'll pass in those entries there, and that'll convert this array of arrays into an object with key value pairs. And then I'm going to pass that to Redux-Leaves. So Redux-Leaves, like, by the way, Redux-Leaves, if we try to use set all properties, this is the thing we're talking about. That's the generic reducer logic we're trying to use. So if we run that again, and then we kind of get down here, and I'm trying to use set all properties equal to 0. Sorry, that came up, I just misran again. What you will see then is it runs it, and it has indeed set all properties at pizzas equal to 0. So let's do, now we can reuse it, which is cool. And I'm going to use it on sushi state. I'm going to set all properties equal to 9 instead, just so we can see the difference. And now I see food, cool, pizzas all have gone to 0, sushi, they've all gone to 9, lovely. And this is now, that's why I called it write once, reduce anywhere, because you write it once and you can use it anywhere, lovely. And one worry you might have with this is you might worry that you're going to be dispatching a whole bunch of glorified setters, because this is maybe the strength and weakness of Redux-Leaves, where it lets you control your state really atomically, but then maybe you've got to dispatch lots of things. Don't worry, there is of course a way you can fix that. There's another export called bundle, which lets you combine an arbitrary number of actions together. So instead of dispatching this single action, I'm going to dispatch a bundle of actions. So what it do, bundle will take an array, and I can put as many kind of Redux-Leaves actions I want in there. So let's also change the event title. Actions event details.title. I'm going to create an update, and I want to update it to the world is having a rave. What else should I do? I'm also going to reset some state. Why not? Actions dot announcements. Got a typo there. Sorry. Details. Actions dot. Sorry, that should be on the night. Announcements. There, I'm going to create a reset action and basically reset that state to what it was originally. Hopefully, Let's see. So if I run that, what I see is in a single dispatch, I've updated the title, I've updated my announcements, it's been reset to the original state, and also my sushi property has still been set. Cool. So I'm going to skip over this because this isn't as essential. But the final thing I want to quickly cover is it works great with use reducer for local state because we don't necessarily want to be locked into Redux. So let's have a very quick look at how we can do that with a code sandbox example. So my code sandbox example, which I am doing here. So I'll whiz through this for the sake of time, but the basic idea of this is a game called Mad Libs, and what we want to do is we want to have like different kind of fields, which eventually, when you complete it, it generates a story. So my name is blah, 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 should come from name. That's what we want, and what you might be tempted to use is use lots of different calls to use state, to like represent all those different like bits of state. Let's not do that. Let's use reducer. And let's say that we have some initial state, because we need initial state for Redux-Leaves. I'm going to give a name, and these, in fact, I'll store these all in fields for reasons you'll see later. And that's going to have name, empty string, programming language, empty string. I'm just going to manually type this out for now, even though, of course, we could automate it a bit easier. Adjective 1. We're also going to ask for a website. We're also going to ask for a library. We're also going to ask for adjective 2. We're also going to ask for, what are the final ones? Verbing and plural noun. And I'm also going to store actually some separate state for is showing, which I'll have as true for now, which is basically, because I only want this to show after I've put generate. So I've created my initial state. I need to import Redux-Leaves from Redux-Leaves. And then I can just pass that. So reducer actions, I'm going to get that from Redux-Leaves, pass in my initial state. Lovely. Then I can use the use reducer hook. That gives me state and dispatch. From use reducer, I'm passing in my reducer I just created. I'm also passing in the initial state as a second argument to use reducer. Here, what I'm going to do is I'm going to do object.entries on state.fields, and that'll give me an array of arrays. I'm going to map that. I'm going to map every single key value pair to something. I'm going to have a field where it's going to have a key because I'm using a map. The label is also going to be the key. The value is going to be the value which I'm storing in my state. I'm also going to give an onChange handler. And my new value is in my e.target.value. My update value action creator is going to be in my actions fields. At that specific key, I want to create an update. And then I'm going to therefore dispatch update value to new value. And let's just spread all out that state here. So I need to spread out state.fields. So let's just check that works. So my name is Steve Jobs. My programming language is JavaScript. Cool. So you can see that that state is actually now updating. And then let's just set that kind of using that show thing. So state.isShowing. So only if state, if that's true, should I render this next bit. Generate, what should you do? You should, of course, dispatch actions.isShowing, create an on action. So let's try again. Richard, oh, that's not working. That's because I should default that to false. Richard, generate. Now that shows, cool. And then, yeah, you might also want to tidy it up. I won't do this now for sake of time, but you might also want to tidy that up here by dispatching a bundle so that when you start typing, you hide this generation, because I think that'd be quite nice. But then, essentially, that is quick whistle-top tour of Redux-Leaves. So the benefits of Redux-Leaves then being that it lets you just basically get on with actually doing it instead of faffing around with modifying your state. So if you'd like to talk, I've written loads of documentation, so you should check out the website. I'd love you to star the GitHub repo, follow me on Twitter, tweet something nice, and it might sound ambitious to ask you to do 3 things, but as we've learned with Redux-Leaves, you can bundle it together and it's actually one single action. So thank you very much, and yeah, I'd welcome you to try it out and let me know how it goes in project.
Amazing tour, Richard. That was awesome. I hope everyone gives you a lot of love in the chats, and understandably a bunch of questions as well. So the first one kicking off with Andrea. Hi, Richard. Is this similar to using Hook's use reducer?
Yes, so thanks, Andrea. So I saw you sent that through before I did a quick user reducer demo. So basically, yes, it's because the use reducer hook is inspired by the Redux reducer API anyway. So if you write a reducer and actions using Redux-Leaves, it's agnostic. It doesn't care whether you use it with Redux or whether you use it with use reducer. So yeah, absolutely. All
right. Next question's from Will. Are there any issues using Redux-Leaves combined with standard Redux actions?
No, there's not. So the only thing, so you can gradually migrate over to Redux-Leaves, and essentially, I will write a guide for this at some point. What Redux-Leaves basically does is, so because it gives you a reducer, you might want to set up a, in your root reducer, you might have to combine the existing reducers that you're using and then do basically a check on actions which come into your root reducer. So you've got a root reducer, check actions coming in, check if they've got a leaf property, I think I call it. If it's got a leaf property, then you should pass it to the reducer which Redux-Leaves gives you. If it doesn't have a leaf property, then you should pass it to the root reducer you were using before, basically. And that way, you can gradually introduce it.
All right. Next question from Lorenzo. Great work, Richard. Does Redux-Leaves work also with TypeScript? And can you...
Yeah, great question. Sorry for cutting you off soon. So it does work with TypeScript. I'm just going to quickly demonstrate that because in the code sandbox demo, which I was doing, you can actually see there is some autocomplete. So actions.fields.library, and this is that autocomplete is come because I've written it using TypeScript. So yes, you can use it with TypeScript, and I'm still writing a TypeScript guide. So things you need to be careful about are which aren't as good with TypeScript as I would like yet. What I would like are there certain things like the push action creator, which should only really work with array state. You shouldn't be able to use it with other types of state. I haven't got the typing down to a point quite with that yet, but definitely you can start using TypeScript.
Okay. From Chris, Redux-Leaves looks great. A couple of questions. What do the actions look like, say if debugging in Redux DevTools? Is there anything that helps with syntax for code suggestions in your IDE?
Yeah, another great question. So here, in your DevTools, so Redux-Leaves creates action types for you. So let's just have a look at one, for example. So actions.onTheNight.announcements create push hello world. So this is just the action, and let's have a look at it. So yeah, so you see there's that leaf property which I was talking about, which Redux-Leaves is using basically. You'll see it's given you this kind of thing, which is meant to be descriptive, but sometimes it looks a little bit unclear. So if you'd rather have something nicer, you can actually modify that. So you can actually here, this is actually a function if you can pass your own action type. So something like announcement made, and then if you run that, you've basically overwritten the type there, and that still works. So just to demonstrate that, you can see it's still pushed hello world, but also you get the nice type of announcement made that you wanted. So if you want to control it, that's essentially how you do that.
Okay. From George, hi Richard, great talk. Can you show to us an example of update an object in an array?
Yeah, sure. So let's look at persons. Let's do actions.onTheNight.persons. And here you've got lots of options. You can actually just go from here if you wanted. So persons dot invisible, I'm going to update that to be like 5 and say that there's 5 invisible people. So now if I look, I see I've got 5 invisible people here, even though that wasn't here. And there's lots of other ways you can do that as well. So an equivalent thing, you could do persons create, you could do a set of invisible to 5. I think that's the API off the top of my head. And that gives you the same thing. So there's lots of different ways you can work with objects.
Cool. Lorenzo asks, how can you manage the side effects of these actions?
So in terms of managing side effects, so these are all, so the demos which I've just been doing has just been updating state. There haven't been any side effects in the sense of like making call from an API, updating from an API. So if you wanted to, so by side effects, I guess you might mean the mutation. So that's something which I guess you do have to be careful about. Like the API is designed in a way where it should be quite hard to accidentally mutate things. I suppose it is theoretically possible if you box something. So I'm still working on like protecting you from accidentally mutating things. But generally with these sorts of things, you're not going to accidentally mutate anything. If you want to work with side effects in terms of like APIs and asynchronous and things like that, then you can use Thunk or Sagas or whatever. And I personally think this works really nicely with Sagas because you've got your Saga doing complex logic and you think about the complex asynchronous logic and Redux-Leaves handles all the silly little trivial details that you don't want to spend your time on.
All right. Cool. Last of the Q&A questions. So Royson asks, how does it support asynchronous operations?
Yeah, and so it doesn't like by itself support async. So that is something where you either use Thunk for or Sagas as you choose. All
right, cool. Last question from me, like, was that pre-recorded? Because that typing was mental fast.
No, it wasn't pre-recorded. I just basically, I used to be a pianist, so I'm used to mad kind of like finger action and that. So.
Okay, cool. Thanks very much, Richard. That pretty much brings us to the end. So I think that went pretty well. I just want to thank all of the speakers again, because it's very stressful, even if you can't see everyone's faces, coming online in front of who knows how many people and giving really great talks, taking questions, doing live demos, which is crazy. So thank you so much to all the speakers. Thank you to my colleagues, Kat and Tiff and Sari, without who this event definitely wouldn't have happened. And most of all, thank you to you for showing up. There'd be no point us hosting these meetups if no one came. So please keep coming, tell your friends, tell your family, bring them along. If you've been inspired tonight and you want to talk, then do let us know. So yep, we'll be hopefully back next month. So keep your eyes peeled with news about that. And all that remains to be said is have a good night. Thanks, everyone. Bye.